Now that we've finally got a decent number of reactions that we've learned, we want to start putting those together and thinking about, one of the main things that organic chemists want to do. And that's, as we talked about way back at the beginning of Organic 1, is the idea of organic synthesis. Organic synthesis is the idea of building up complex molecules from simpler starting materials. And so the thought here is really, how do we make complex molecules? And while we're not going to be working with anything terribly complicated right now, we can start with some very simple examples that still show us the same principles. So what if we wanted to make this compound here? And let's say that we had some acetone to start from. So in other words, we're going to take acetone, and in a series of reactions, we want to figure out how to convert acetone into our compound that we've drawn on the left. Now, there are two ways to approach this. We could start with the acetone and think about what we could add to acetone to go stepwise to get towards our product. And oftentimes for simple syntheses, ones that are only going to be a couple of steps, that type of process can work okay. That being said, the more complicated these get, the harder that becomes, because often there's just too many options trying to move forward to determine what our correct path is or what our best path is. The second thing to keep in mind as you get into these types of problems is there's often going to be more than one correct answer to these questions. Oftentimes we could come up with multiple routes that would successfully get us from our starting material to our products. But ultimately what we do as chemists is it makes more sense and it's a lot easier to work backwards, or use what we call retrosynthetic analysis. Retrosynthetic analysis is the process of starting with the product and working our way back to the starting material. And it becomes a little bit easier to think about it in terms of what we need to add to get back in that direction. So let's start with this example and look at it in that regard. Always keep in mind we're trying to get back to acetone. Now, right now, the syntheses we're going to do are going to be relatively short, 2 to 3 to 4 steps. As we go further and further through this course, as we learn more reactions, as we get more comfortable with synthesis, some of our syntheses are going to get longer and longer. So one thing we might want to consider here is if we look at where we're trying to go, is there any part of this molecule that we could say, this is the piece that comes from acetone? Well, acetone is, of course, a 3-carbon molecule. And coming off of the aromatic ring here, we have 3 carbons. So it might be a logical starting point to think that those 3 carbons are the 3 carbons of acetone. Now, where's this oxygen? Well, it's not in the product, but the product has an alkene. And we do know, we learned in the elimination chapter, that we can make an alkene from elimination. And it could be elimination of any leaving group, but given that we have an oxygen in our starting material, it might be logical to have it be an alcohol. Now, whenever we use this arrow that looks like this, that's an arrow that means retrosynthetic. So it means that the compound on the left here is made from this molecule. Now, again, we can start to see that this section here kind of resembles acetone. But we still have an aromatic ring that we've got to somehow add. Now, at this point in the course, seeing that we've added a carbon group should really push us in one direction. At this point, we haven't learned, really any ways to make carbon-carbon bonds outside of a Grignard addition. So we could, use a Grignard, bring in the phenyl ring, the aromatic ring, that gets added to the carbonyl of acetone, and that gives us our compound here. Now, if we were doing this as a synthesis, we wouldn't yet be done, because all we've done is our retrosynthetic analysis. And it can often help as we're doing it to label what the reactions are. The synthesis would be the forward direction. So what does that look like? So we said we're going to take acetone, our starting material. We're going to add the Grignard reagent. And remember, we typically quench that with acid. Gives us our alcohol, which then, given that this OH group is both tertiary and adjacent to an aromatic ring, we can easily eliminate it, dehydrate it by adding acid, which gives us our product. So this is the thought process that we want to go through when we look at a synthesis question. And so because we approach most synthesis problems in a retrosynthetic way, working backwards, this means is you're learning your reactions, both the ones that you've already learned as well as the ones we're going to learn in the future. Not only will you want to learn them going forward, so starting materials, reactants, what products do they form, but you're also going to want to learn them in the other direction. Here's the products. What starting materials would form those products? All right, so let's look at another one. So now we want to make we're going to attempt to make this diol starting from this alkyne. And so again, it's the same type of thinking. What are the pieces in one compound that correspond in the other? How do we make what we see in the product? And so the first thing I see looking at this product is we have this diol. Not a lot of ways that we know of to make a diol. And probably the easiest way to make a diol that we've learned is to do a dihydroxylation reaction. A dihydroxylation takes an alkene and adds alcohols to both carbons. Now, here's an alkene. The starting material has an alkyne in it. Well, we've also learned that alkenes can be made from partial reduction of an alkyne. And now the only difference between our compound here and our starting material is a methyl group. Now, at this point, we don't know a lot of ways to add methyl groups. But in the case of a terminal alkyne, we know that we can deprotonate a terminal alkyne and add an alkyl halide in an SN2 reaction to get an extra carbon group on there. So that, again, is our retrosynthesis. How do we go forward now? Well, we're going to take the same steps, and now we're going to draw the arrows going forward. As you can see here, I'm not even getting rid of the structures. All we're doing is getting rid of the retrosynthetic arrows, and now drawing with forward arrows. So, to put the methyl group on, we first need to deprotonate the alkyne, and then add in the correct alkyl halide, which is in this case just the methyl group. We need to then reduce the alkyne to the alkene. We can do that with lithium and ammonia. That would give us the transalkyne we've drawn. And finally, we can do our dihydroxylation using osmium tetroxide and NMO. And that's really all there is to it. As I said, these types of questions are going to become more and more complicated the further we progress in this course. And that's because we're going to be learning additional reactions. Right now, we're kind of limited to just a couple steps on these types of syntheses. But we'll do one more here. And then, as you know, you've got a practice sheet with some examples to do. All right, so again, we have, now in this case, a halohydrin. And we should recall that if we have a bromine next to an alcohol like that, that's something we can form through the halohydrin reaction, the addition of bromine and water. That means this would have to come from corresponding alkene. Now, again, there's only two ways that we know of right now to add new carbon groups. Alkylation of an alkyne, which, given that we've got an aldehyde here to start, probably won't help us very much, or Grignard addition to a carbonyl. So if we think of these three carbons here as the three carbons on the left, and we know if we add a Grignard, that means we're going to result with an alcohol. So we could do dehydration, and then we could get back here using a Grignard. Again, that's our retrosynthesis. Now what's the forward synthesis? We can do the same thing we did a moment ago. We'll get rid of our retrosynthetic arrows and put in the forward arrows. So here we're going to add a Grignard, specifically the one with 4 carbons like this, quench with acid. We'll then do a dehydration to go from the alcohol to the alkene. and then the addition of bromine and water gets us to our product. So from here, you should look at some practice. This is, at this point, in class exercise number 5, which works on synthesis. And the next video, I'll go over the answers to that exercise.